And so the next constellation in the sequence is Auriga, Orion's charioteer, and the star Capella is actually a four-star system. Capella itself, what we see as Capella, is actually a binary pair, and they're both red giants, so they've completely evolved off the main sequence. They're on their way towards final collapse, and they are also orbiting with a pair of red dwarf main sequence stars that are orbiting quite a large distance away, but they are still gravitationally bound. Boötes, constellation Boötes, with the star Arcturus. Arcturus is also class 3 K, so it is an orange red giant starting its transition history. Canis Major, Canis Minor. Canis Major with Sirius. Sirius is a main sequence star. It has a white dwarf companion, and so does Canis Minor. Canis Minor is actually a subgiant. It's now moving off the main sequence, started its sequence of evolving, and it also has a white dwarf companion. Carina is a constellation in the southern hemisphere. It has two very rigorous star formation areas there. NGC 3603 has young clusters, open clusters of stars in the center. It has a lot of star formation going on there. And of course, there is the great Carina Nebula. This nebula is only about 20,000 light years away, and it's in a direction that has very low visual extinction, and it's very compact and very bright. So it's very easy to see details within this particular star formation region. And you see everything in this region. Blue areas where radiation from massive forming stars is being reflected, the reddish areas where gas and dust has been heated, and it is radiating in the red from the hydrogen that's there. And also in this particular area is the massive supergiant Eta Carina, which astronomically speaking could collapse any day. It is now about 120 solar masses, and when it does collapse, it will outshine any object and every object in the Milky Way galaxy. There are at least a dozen 40 to 100 solar mass stars in this particular region, and it's also a rigorous supernova event and remnant area, because if you're creating lots and lots of really massive stars, the more massive it is, the shorter the lifespan. So it doesn't take too long for them to start collapsing into supernovas. So when you have a very rigorous star formation area like Carina is, you also see a lot of supernova remnants. Cassiopeia, the constellation of Cassiopeia, has 4 deep sky objects in it. 2 of them are supernova remnants. Cas A is a Type 2 supernova remnant. It is the core collapse of a massive star that is the definition of a Type 2 supernova remnant. A star collapsed into and left a neutron core behind, the stellar core. Type 2 supernova collapses end up producing stellar cores that are neutron stars or pulsars or black holes if they're massive enough. Tycho is the other kind of supernova remnant. It is a Type 1a. There is no stellar core here. Tycho was a white dwarf that accreted too much material to remain stable as a white dwarf, which initiated a runaway fusion event in the core, which resulted in a thermonuclear explosion that literally blew the white dwarf into a remnant, and that is all that's left behind. In Cassiopeia, there is also NGC 281, which is referred to as the Pacman Nebula, and it is a region of star formation. Again, you can see the common features. You can see the dark absorption clouds where the gas and dust is more opaque. You can see the blue reflection nebulas and the reddish emission nebulas. You can see around the edges the the pillars of gas and dust that are being carved away by the radiation of the massive stars that are forming there. On the right is a star formation region called W3 main, and this is a Chandra X-ray image on the top, and on the bottom is an optical image, and you can see that there's a huge amount of gas and dust in this particular star formation region. But you can see in the X-ray one that there are a lot of stars being formed there, some pretty massive stars being formed that are emitting in the X-ray. And this is thought to be, once the Orion Nebula, which is much older and sort of getting low on gas and dust to form new stars, when that becomes too faint to see as that part of the sword in Orion's sword, that W3 main will be the next Orion Nebula, will be the next major star formation region in our local neighborhood. In Cygnus, the star Deneb is a luminous supergiant, luminosity class 1, and also in that constellation is Cygnus X1, which is a black hole, which means it is the end result of the core collapse of a massive star, Type 2 supernova event, left behind a 14 to 15 stellar mass black hole. It happens to have a companion star that is still on the main sequence. It hasn't started evolving yet, but this black hole is accreting material from its companion star, producing an accretion disk, and particles of matter and antimatter are spewing out along the rotational axis. This is called an X-ray binary system, and it is thought that the progenitor star, which collapsed into Cygnus X1, was about 40 solar masses. Next constellation is Dorado, and Dorado is in the southern hemisphere, and within Doradus there are two deep sky objects. One is the Large Magellanic Cloud, and that is about 160,000 light years away. Now, the Large Magellanic Cloud has always been classified as an irregular dwarf galaxy to the Milky Way galaxy, but they're changing that classification. They now suspect that it used to be a barred spiral galaxy, and it was disrupted by a close encounter with another galaxy. So now it is referred to as a disrupted barred spiral galaxy. And within the Large Magellanic Cloud, on the left-hand side, there is a bright knot area in there, and that happens to be 30 Doradus, which is also commonly referred to as the Tarantula Nebula. And the Tarantula Nebula is the largest star formation region in the local galactic neighborhood. And so it is observed and analyzed by multi-wavelength missions all the time. It's a very important area for star formation. In Gemini, there are two stars, Castor and Pollux. Castor is actually a 6-star system comprised of 3 binary pairs, all gravitationally bound to each other. Pollux, which appears brighter and a little bit orangey or yellowish, is a red giant star, which will eventually collapse into probably a planetary nebula with a white dwarf. In the constellation Hydrus, now Hydrus is a new constellation this year, not to be confused with Hydra in the northern hemisphere, the water snake. Hydrus is the lesser snake in the southern hemisphere, and you can see that it lies between the small Magellanic Cloud and the Large Magellanic Cloud. So it neighbors the Large Magellanic Cloud on one edge, and the Large Magellanic Cloud is mostly in the constellation of Dorado, but some of it kind of hangs over into Mensa. The small Magellanic Cloud is mostly into Cana, but some of it kind of laps over into Hydrus, so it's in that particular constellation also.